Welcome to Ms. Parb's Flipped Classroom. Today we're going to review factoring and using your factoring flowchart. I know this is probably too small for you to read, so you should make sure that you have your own copy of your factoring flowchart in your hand as you're working these so you can look at it. To use your factoring flowchart, you start in the upper left-hand corner and you ask yourself, is there a greatest common factor? If the answer is yes, you follow the path this way and just continue on following the path. If it's no, you go this way and once again just continue to follow your path. So let's look at some examples that we can work using our factoring flowchart. So we look at this expression and we ask ourselves, is there a greatest common factor? 1 and 36, an x and a no x. So the answer is no, there is not a greatest common factor. The next question is, do we have two terms? And the answer is yes. So we go over here and it says, is it the difference of two perfect squares? That's a perfect square, that's a perfect square, and we're subtracting. So the answer is yes. And then it tells us to factor using a squared minus b squared equals the quantity a minus b times the quantity a plus b. So we take the square root of our x squared, which is x, and the square root of our 36, which is 6, and we have our answer. Notice the circle stops here. There's no more questions or arrows. That means you're done at that point. Okay, the second problem, 5x squared minus 5. We start up here again. Is there a greatest common factor? And this time the answer is yes. So we go over here and it tells us to factor out the greatest common factor. So that would leave us x squared minus 1. After we've done that, we go down to the next question. Are there two terms inside the grouping symbols? Meaning, are there two terms in the parentheses? And the answer is yes. So we go over here. Is it the difference of two perfect squares? The answer is yes. So again, we factor this. Bring the 5 over. The square root of x squared will be x. The square root of 1 is 1. Okay, our next problem. Is there a greatest common factor? If you look at this, you'll realize there is not a greatest common factor, so we say no and go down here. Two terms, well, we have 1, 2, 3 terms, so the answer is no. 3 terms, the answer is yes. And it says, can you find two numbers whose product equals AC and whose sum equals B? So they're telling us to do the AC test to work this problem. Well, A equals 1, so we know that this is our easier kind of problem to work. C is a negative 14, and B is a negative 5. So some of our factors of 14 would be 1 and 14, and 2 and 7. Since this is negative and this is negative, one of these numbers is negative, but the other one is positive. So we're going to have a negative 7, because 2 times negative 7 gives us a negative 14. And 2 plus a negative 7 will give us a negative 5. So this is the combination that we want to use. So remember, since A is 1, we just take x, and then the numbers that we're going to use are a positive 2 and a negative 7, and that's our answer. Let's look at some examples that are a little bit more complicated. Okay, if you look at your factoring flowchart once again, is there a greatest common factor? The answer is no. Are there 2 terms? No. Are there 3 terms? No. Are there 4 terms? Yes. And it tells you if there are 4 terms to group them, and then look for a greatest common factor just in the expression with the binomial. So 6x squared and 2x, our greatest common factor would be 2x. When we divide that by 2x, we get 3x plus 2x divided by 2x would give us 1. 9x plus 3, our greatest common factor would be 3. 9x divided by this 3 leaves us 3x plus 3 divided by 3 would be 1. So now we have the same thing, same expression in the parentheses, so we can factor that out. So we have 3x plus 1 as our greatest common factor between these two. And when we divide this by 3x plus 1, we have 2x left over. And when we divide this by 3x plus 1, we have our 3 left over. and this is our answer. Okay, in the last example, our first question is there a greatest common factor? Well, we have 12, 34, and 10. And 2 will divide into all of these numbers. I know that because they all end in an even number. This one does not have an x, so there isn't a variable that we can take out, only a number. So we're going to take out the greatest common factor of 2. So when we divide that, that leaves us 6x squared plus 34 divided by 2 leaves us 17x plus 10 divided by 2 leaves us 5. So the 2 is still going to be part of our problem. And now inside the grouping symbols, we have 3 terms. So when it asks about 2, it's no, 3, yes. So if there's 3 terms in here, that means we want to do the AC test. A is 6, C is 5, so our AC is going to be 30 because we have to multiply these two numbers. And our B is 17. So some of the factors of 30 would be 1 and 30, 2 and 15, 3 and 10. And we notice that 2 and 15 multiplies to give us 30, and 2 plus 15 adds to give us 17. So we are going to use these to rewrite B. Because remember, since A is not 1, we have to rewrite the middle term and then group it. So we're going to have our 6x squared, and then in place of 17x, we're going to put 2x, and over here, we're going to put the 15x. These are the two things that add up to give us our 17x that we figured over here. And then our plus 5 is just going to come down. Okay. We just keep bringing down this 2 that we took out at the very beginning. Now we look at 6x squared and 2x and ask ourselves, what is the greatest common factor in these two terms? And the answer is 2x. So when we divide that, we get 3x plus 2x divided by 2x is 1. And now we look at 15x and 5, and we know that both of these are divisible by 5. So we can take out a 5. That would leave us 3x plus 1. Well, our 2 is still part of our final answer. We just keep bringing it down. We look inside the grouping symbol, and we notice that this 3x plus 1 and this 3x plus 1 expressions are the same, so we can factor that out. And that leaves us our 2x plus 5. And that is our completely factored answer for this trinomial. And this is kind of a quick review of most of what we've done in factoring, and it gives you an idea of how to use your factoring flowchart. You will be allowed to use your factoring flowchart on your test in class, so make sure you hang on to those.